In this section, we start with the concept of resolution of a vector. Resolution of a vector basically means that a vector is divided into two components. In two dimensions, it is divided into two components. In three dimensions, it is divided into three components. For simplicity, we consider two dimensions. The concept of resolution of vectors in two dimensions can be easily extended to three dimensions also. Therefore, we need to concentrate only on two dimensions that can be easily extended to three dimensions. In two dimensions, any vector can be represented as a combination of any other two vectors. That is, if you have three vectors, the third vector can always be expressed as a combination of the other two vectors. If it is in three dimensions, any vector can be represented as a combination of three other vectors. The only condition is that the other two vectors should be non-collinear. They should not lie along the same line. Therefore, we can see that if you have a vector, it can be represented in terms of two other non-collinear vectors in two dimensions and three other non-collinear vectors in three dimensions. But in physics and most cases where vector analysis is applied, we divide or we resolve the vectors into two mutually perpendicular directions. That is, one in this direction and other in this direction. Two mutually perpendicular directions. We will be dividing into two mutually perpendicular directions. It need not be mutually perpendicular, but usually in practice we consider mutually perpendicular directions. And here in this figure we can see that this vector R can be represented as the sum of two mutually perpendicular vectors P and Q. And we say that the vector R is resolved into two vectors P and Q. This vector P is called the horizontal component or the X component, and Q is called the vertical component, that is the Y component. In three dimensions you will have a C component also. Therefore, a vector resolved in this manner is usually called resolution to rectangular components. Rectangular to mean that they are mutually perpendicular. It need not be, it can be oblique, but the most of the applications are there for mutually perpendicular resolution. The vectors are resolved into two mutually perpendicular directions. Therefore, we can find for any vector an X component and a Y component. To make it more meaningful, we find a method to represent a vector in terms of unit vectors. Consider a vector A. We consider a vector A. We can imagine another vector in the same direction of A and having a magnitude of 1. For example, imagine this is a vector. This vector represents 5 Newton. And by scaling, we take this as 5 centimeter long. Then I can imagine a vector having 1 centimeter length and direction same as this vector. if I take 1 centimeter here, 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 that will totally give me a 5 centimeter long vector. Therefore, I can represent this vector as a product between 5 and this unit vector. Therefore, that vector is called a unit vector. In terms of unit vector, any vector can be represented as a number multiplied by unit vector, where unit vector is the vector which is in the same direction as that of the original vector and having a magnitude 1. If you take this example, I have a 5 centimeter long vector. I have a unit vector 1 centimeter. If I want to get the unit vector, I simply take this vector A and divide it with 5. 5 is the magnitude of this vector. Therefore, a vector divided by its magnitude will give you the unit vector. How the magnitude of a vector is to be determined, we will see subsequently. And we take some vector, find its magnitude, that will be a number, divide the vector with that number. That will give me the unit vector. So that is the procedure. Therefore, we can see that vector A can be represented as a product between the magnitude of A, that is modulus A, multiplied by the unit vector A. Any vector can be represented like that. A vector, it can be represented as modulus of that vector multiplied by the corresponding unit vector. That is, vector A is equal to modulus A multiplied by the unit vector A. But in practice, we usually divide the vector into two mutually perpendicular directions in two dimension, or three mutually perpendicular vectors in 3 dimension. Therefore, we use the concept of a unit vector along the x direction, y direction and z direction. You consider x direction. For example, this is the x direction. You take a 1 centimeter length here along the x direction. That will give you a unit vector along the x direction. You take, this is the y direction, and in y direction you take a vector in the y direction with a magnitude of 1 centimeter or 1 meter or 1 unit. That will give you the unit vector along the y direction. You can take the c component, this is the c vector, and you can take 1 centimeter and along that direction, that will give you the unit vector along the c direction. And they are given a name. We use the x, y, z directions unit vectors for various purposes. Therefore, it has got a special name. X direction, the unit vector is represented by the letter I with a cap symbol or caret symbol at the top, I cap. Similarly, y is written as j cap, z, c is written as k cap. And the vector A, we have, if you write in that manner, we have the vector A as the vector Ax plus vector Ay. That is the resolution of vector A into x component and y component. But we can write the Ax as the modulus of Ax or the magnitude of Ax multiplied by I. Ax is equal to modulus Ax multiplied by I. Usually, we ignore the modulus sign. When we write the x component, we ignore the modulus sign and we simply write it as A sub x. When you write A sub x without a line at the top, A sub x simply means that it is the magnitude of the component of that vector along the x direction. magnitude of the component of that vector along the x direction. That is magnitude of ax. That is represented by a sub x. And therefore, the vector ax can be written as axi. Similarly, ay can be written as ayj. Thus, any vector can be represented in terms of I and j. Since A is equal to vector ax plus vector ay, vector ax is equal to modulus axi, which is written as a sub xi, and vector ay is modulus ayj, which is written as a sub yj. Then we can write vector a as axi plus ayj. In the c direction it is k. Therefore, in 3 dimensions we can write a vector a as axi plus ayj plus ack. Using this procedure, sometimes in problems, most of the times in problems, the vectors will be given in this component form instead of giving it as a directed line segment. Instead of giving it as a directed line segment, it is usually given in the component form. Component form means you are given that you have a vector A, which is axi plus ayj. For example, this is 3, this is 2. Then this is 3i plus 2j represents ay. Similarly, you have another vector B. Say this is 1 and this is 1. That is 1i plus 1j. That gives you by. B. bxi plus byj. Then, to add these two vectors, that is to find the value of a plus b, you simply add the x components. That they are two numbers, they are modulus, therefore numbers. You add those two numbers or subtract if it is minus. Algebraically sum those two, ax plus bx, and put an I there. And similarly, you add bx and by and put a j there. For example, this is 2, this is 2, this is 1, this is 1, this is 1. Then you have ax plus bx as 2 plus 1i plus 2 plus 1i j. That is 3i plus 3j. Therefore, you can add vectors without drawing the diagrams or applying parallelogram law and triangular law. Instead of that, you can use the component form. If you have 10 vectors to add, you don't need to use the polygon law of vector addition. You simply add the x component of all those 10 vectors, put an I, then add all the 10 components of y components and add a j, take all the 10 c components and put a k. Then you will get sum of x components I plus sum of y components j. If it is 3 dimension plus sum of c components k. Therefore, that is the addition of vectors using component form. If it is given in component form, that can be added. They can also be multiplied, but the multiplication we will see in a later section, not now. When we learn the work energy power chapter, we will see the products between vectors. Now we are not handling products, we are only handling sum. And these components of a vector can be represented in terms of the vector and angle it makes with the axis. Here I have taken a coordinate system and I have drawn a vector A. This vector A is inclined at an angle theta to the x-axis. Therefore, the formula which I am going to write is applicable when the vector is inclined to the x-axis by an angle theta. Usually, the angle with the x-axis is given. But you should be careful. Sometimes in question the angle about y-axis will be given. What you should do, I will tell you later. Therefore, now we take the angle, say this angle is 30 degree or this angle is 45 degree and this A is 5 Newton, something like that. That is given. Then we can see from elementary trigonometry that sin theta is equal to ay divided by a, that is opposite side by hypotenuse, and cos theta is ax divided by a, that is adjacent side divided by hypotenuse. Therefore, ax divided by a is equal to cos theta, ay divided by a is sin theta. You can therefore write ax in terms of a and theta, that is ax is equal to a cos theta, ay is equal to a sin theta. So, the components of the vector can be written using the magnitude of the vector a. This is the magnitude of the vector because ax is a number. A is the magnitude of the vector and cosine theta is the angle. So, ax and ay are two numbers that can be obtained. If this is 30 degree or 60 degree and this is 6 Newton, then this component will be, x component will be 6 into cos 60, that is 6 into 1 by 2, that is 3 Newton. This will be 3 Newton if this is 6 Newton and this angle is 60 degree. And this will definitely be a multiplied by root 3 by 2 or 3 root 3. This will be 3 root 3. Therefore, if the vector and the angles are given, we can calculate the components. Components can be calculated. And if you are given two relations in that form, in everywhere in physics and mathematics, if you get something in the form of a cos theta, sin theta form, the most natural thing you do is to square both and add them. Because we know the wonderful relation cos square theta plus sin square theta is 1. Therefore, so we square ax to obtain ax square as a square cos square theta and ay square as ay square sin square theta. Add them together, that will become a multiplied by cos square theta plus sin square theta. Cos square theta plus sin square theta will be 1. Therefore, a can be written as, a square can be written as ax square plus ay square. And therefore, so we can write a is equal to square root of ax square plus ay square. That is the magnitude of a. So, magnitude of any vector can be written as square root of ax square plus ay square. So, if the vector magnitude and the angle is given, we can calculate the x component and y component, and also we can calculate the magnitude of the vector. And from that figure we can see that opposite side divided by adjacent side is ay divided by ax, and that is tan theta. This is again tangent law. Tan theta is equal to ay divided by ax. If you look at that figure, you can see that if this angle is theta, this angle is given as theta, this will be a cos theta and this will be a sin theta. If you are given an angle, the axis nearer to that is cosine and farther to that is sine. If the angle here it is given theta, this will be cosine and this will be sine. So we have to take care of where, from about which axis the angle is given. If the angle is given about the y axis, the relations will switch off, switch between those two. Sine will become cos and cos will become sine, and tan will become ax over ay instead of ay over ax. Now, using this law, we can write a, because ax is known, ay is known. If ax and ay are known, A can be written as AXI plus AYG. That is our basic rule. Now AX is equal to A cos theta, AY is equal to A sin theta. Therefore, A can be written as A cos theta I plus A sin theta j. In 3 dimension, obviously, we have AXI plus AYJ plus AZK. But dividing or writing in terms of angles is applicable only for 2 dimensions, because we are taking only an angle and a length. In order to extend that to 3 dimensions, it is slightly more complicated. We have to use different types of other coordinate systems called spherical polar coordinate systems, etc. That is not dealt with here. We need only 2 dimensions. In our applications to plane motion, which we are going to see in the continuation of this, that in plane motion we need only vectors lying in a plane. That is coplanar vectors. They are called coplanar vectors. Vectors lying in a plane are called coplanar vectors. We take an example. X and Y components of velocity are 4 meter per second and 3 meter per second respectively. Find the magnitude and direction of the velocity. That is, we want to find the magnitude V and also the direction. Direction is the direction made with the x-axis, because what angle it is making with the x-axis. Vx is equal to 4 meter per second. Vx is equal to 4 meter per second. Vy is equal to 3 meter per second. V is equal to square root of Vx square plus Vy square. Vx square is 4 square. Vy square is 3 square. Therefore, square root of 4 square plus 3 square is square root of 25. That is 5. So, the magnitude of the vector, which has x component 4 meter per second and y component 3 meter per second, is 5 meter per second. If you take a point here, you move 4 meter here, 3 meter here, that will be equivalent to 4 meter per second in this direction, 3 meter per second in this direction, that is equivalent to moving in this direction as 5 meter per second. The components are 4 meter per second along the x direction and 3 meter per second along the y direction. So, if you move 4 meter per second along the x direction and 3 meter per second along the y direction, the resultant velocity will be 5 meter per second. It is usually called the resultant of 3 and 4. X component and y component of velocities, and the resultant velocity is v. To find the angle, we use Vx over Vy is tan theta. Here Vx is 3, Vy is 4, tan theta is 3 by 4, and 3 by 4 is tan 37. Therefore, theta is equal to 37. So, we have a vector having magnitude 5 inclined at an angle 37 degree to the x-axis. If in the question the angle asked is for y-axis, this will be clearly 53 degree. This will be 53 degree. Next example, find the component and x component and y component of the vector shown. Here we have given a 10 Newton. This is 30 degree. X component is a cos 30. A is 10. Therefore, 10 multiplied by cos 30. Cos 30 is root 3 by 2. Therefore, Ax is 5 root 3. Ay is a sin 30. 10 sin 30 is 1 by 2. 10 multiplied by 1 by 2 is 5 Newton. Therefore, if this is a force 10 Newton, its x component will be 5 root 3 Newton and y component will be 5 Newton. This is 5 Newton, this is 5 root 3 Newton. The resultant will be 10 Newton. If you take a body and apply 5 root 3 Newton in this direction, you take a string and pull it in this direction with 5 root 3 Newton. Take another string and pull it in this direction with 5 Newton. Then this object will move in that direction. making an angle 30 degree in the, as if 10 Newton is acting in this direction. Therefore, this force, that is 5 root 3 Newton applied in this direction and 5 Newton applied in this direction, is equivalent to a 10 Newton applied in this direction, making an angle 30 degree. That is the meaning of that question. A plane takes off at a velocity 150 km per hour, making an angle 60 degree with the ground. This is the ground. This is the taking off of the plane. This angle is 60 degree with the ground. Calculate the horizontal and vertical component. It is same as the previous problem. Vx is equal to v cos theta. Theta is 60 degree. 150 multiplied by cos 60, that is 150 multiplied by 1 by 2, that is 75 km per hour. Vy will be v sin theta, sin 60. 150 multiplied by sin 60 is root 3 by 2, so 75 root 3. Therefore, the plane which is moving at 150 km per hour, making an angle 60 degree with the horizontal, is equivalent to 75 km per hour in this direction and 75 root 3 km in this direction. Remember that it is not compulsory to take the components of a vector along the horizontal direction and vertical direction. Sometimes in problems, we will have to change that. We take the components in mutually perpendicular directions. That can be in inclined directions also, but in most of the problems, we resolve a vector into two mutually perpendicular directions. But those two mutually perpendicular directions need not be the x-axis and y-axis. They can be different directions. And in some problems, some questions we have to use that idea. For example, you consider an object which is placed on an inclined plane like this. It has a mass m and it has a weight mg which is acting vertically downward. Gravity always acts vertically downwards. Now, we want the components of the vector. We do not take the component along the x-axis and y-axis as usual. Instead of that, we take the component along the incline and perpendicular to the incline. That is, they are not x-axis and y-axis. That is, along the incline and perpendicular to the incline. We take in that manner, that is not x and y. In questions, we need to use that in some situations, particularly when inclined planes and forces acting in inclined directions, etc. are coming. Sometimes we will have to resolve the vectors into two mutually perpendicular directions which are not x-axis and y-axis. We can treat this of the x-axis and this of the y-axis, no harm. But usually we take this of the x-axis and this of the y-axis. We can always rotate the coordinate system and make it like this. That is possible. Usually, therefore, this is w sin theta, this angle is theta. Therefore, the component nearer to theta, that is w cos theta, component farther to theta, that is w sin theta. This weight can be resolved into a component along the incline, that is w sin theta, and perpendicular to the incline, that is w cos theta. A vector has components of 3 units along the x direction and 5 units along the y direction. What is the vector? We know that a vector can be represented as axi and ayj. Here, ax is given as 3 units, ay is given as 5 units. So, the vector will be 3i plus 5j. Another example, a vector has 7 units along x-axis, 10 units along y-axis, minus 3 units along z-axis. What is the vector? 7 units along the x-axis means ax is 7. 10 units along the y-axis means ay is 10. Minus 3 units in the c-axis means ac is minus 3. Therefore, the vector will be 7i plus 10j minus 3k. This will be the vector. A particle, this is a slightly advanced level question. A particle moves with a speed 10 meter per second in a plane along a vector a equal to 4i minus 3j. Find the velocity vector. We are given that, we are not given the exact x component, we are not given the y component. Instead of that, we are told that that velocity vector is along another vector which is given. That velocity vector is along a, and therefore that is 4i minus 3j. So, the unit vector of the velocity vector will be same as the unit vector of a. We know how to calculate the, then if a cap is the unit vector along a, our velocity will be magnitude of v multiplied by the unit vector along a, because velocity unit vector is along a. A vector we know, therefore we can calculate the unit vector along a. You multiply that unit vector with velocity, you will get the value which is the velocity vector, magnitude multiplied by unit vector. Now, we know how to calculate the unit vector. That is, we take the vector, divide it with the magnitude of a. A vector divided by its magnitude will be the unit vector. We know how to calculate the magnitude. If ax and ay are given, the magnitude is square root of ax square plus ay square, that is the magnitude. So, ax is given as 4, ay is given as minus 3. So, ax square plus ay square is 4 square plus minus 3 whole square. And at the top, we have axi plus ayj, that is given as 4i minus 3j. So, we can calculate the unit vector a. This is not unit vector, this is the vector a. This is the vector a. Vector a, 4i minus 3j, sorry, unit vector a, this is, we are dividing this with the magnitude, therefore this is a. This is a, capital A, this is the magnitude. Root of ax square plus ay square, that is the magnitude. Root of ay square plus ax square plus ay square is root of 4 square plus 3 square, that is 16 plus 9, square root of that, square root of 25, that is 5. And the numerator we have 4i minus 3j. So, the unit vector a will be 4i minus 3j divided by 5. So, v will be 10 multiplied by this x component of, this is the unit vector, 10 multiplied by unit vector 4i minus 3j divided by 5. 5 and 10 will cancel, there will be a 2. Therefore, this is 8i minus 6j. So, the velocity which we are asked is 8i minus 6j. So, that is the answer.